Hello and welcome. In this video, I will discuss some design patterns that you can use to develop apps for Microsoft Dynamics 365 Business Central. These are just a very few of the design patterns that are available throughout the base application, but they represent some of the more important ones. My name is Daniel Rimmelswan, and I am a partner with Cloud Ready Software, one of the ISV development centers that can help you with just about anything related to Business Central. I want to also take this opportunity to thank Erik Wouters, also known as Waldo, who's one of my fellow partners at CRS, for providing the content of this video. Let's take a look at our objectives. First, I'll talk about how you can apply software design as a methodology itself. So this is where I'll discuss how you can use the awareness of design patterns as a tool in thinking about how you're going to implement business requirements in your app. Next, I'll talk about some of the design patterns specifically and the elements that make them so powerful. And then finally, we'll cover how Visual Studio Code snippets can be used to help you implement those design patterns. The first section is applying software design as a methodology. What you need to be aware of is that we are talking about an event-based software architecture. And in that context, I'll talk about agents, I'll talk about encapsulations, decoupling, and readability of your code. And these four concepts are very important when you think about event-based software and about properly applying software design to a business application when you link the methods and the functions in your business application to the specific technical software design that you are going to apply. So you have a business requirement and you've decided that you have a function, and the function is a function of the purchase order, and that function is creating a pallet. And so from your purchase order, you want to create a pallet. And so then your next decision is, okay, I'm going to implement a function, some logic, some code, and I'm going to program this process where I'm going to create a pallet based on some variables and some values that are within my PO. So then your first, one of the first decisions that you'll make is, where do I put this new code, right? So you can visualize, you're looking at your purchase order screen and you have a button on your screen that says create pallet. You can have an action on your screen. So in our screenshots, we have a page extension for the purchase order subform. And on that page extension, we have an action called create pallet. And we've programmed that action to do the actual thing itself. That's one thing to do, one way to go. This is, of course, not the correct way to go, because now we have business logic, the actual business logic on the page object, which is not the right place for business logic to live. So business logic should not live on a page object, not in the least, because you want to be able to reuse this perhaps in other spots in the system, and you don't want to have to create variables based on a page where you can then use the action code in there, and it becomes very messy that way. So the next layer in maybe is the table. Maybe we can create a table object, and in the table object we have a procedure called create new pallet, and we can call it from there. So in this case, in this screenshot, we have a table extension object that extends the purchase line table, and in there we have a function that creates a new pallet. This is better than on the page, because this way you can call the create new pallet function anywhere that you have a variable based on the purchase line. But still, this is still part of your purchase line. So anytime that there is a change on this, you have to go into the purchase line table in order to make a change to create new pallet function. So you have the create new pallet function as a business piece of business logic, but it is contained within the scope of the purchase line. So instead of working on, the new palette functionality, you're working on the purchase line in general. And so you might work on create new palette. Somebody else might work on, a different function, and now you're working in the same object, and it becomes very messy because now this one object contains logic for a whole bunch of different purposes. And so again, it's better than having the code on the page, but still it's not really the best option. So then, and this is quite common, we could create a management code unit. And this is common in a lot of applications. A lot of ISV products, a lot of verticals and add-on products have some sort of notion of a management code unit, which is almost a functional collection of functions that provide different pieces of functionality. So you would have a palette management code unit, and within that you have, create new palette, and you can see in the bottom of the screenshot, you have assign palette to purchase line. Maybe there are some other functions as well, and there's probably some common logic that, are used by different methods. This is even better than having it on the page, certainly. Also better than having it on the table, but still now you have a code unit that has different methods for different purposes inside the scope of a single code unit. So it's still not optimal. So you might think, well, does it matter? Because the computing result will still be the same. It doesn't matter whether the code is on the page or on the table or in a collection code unit, a management code unit, the result is the same. So whether the action code has that function or whether it's on the table or wherever, that logic executes and the result is the same anywhere. Anyway, there are a number of aspects that you have to think about. Think about transparency. Think about testability, your ability to upgrade or to easily expand or repeat, reuse the functions that you create. If you think about all these aspects, you might come up with a way to reduce the total cost of ownership. It minimizes the risk and opens up possibilities for, all these different ways of designing your software. And so it does matter where you put code, because you want to have a system in which the way that the code is written, the way that these technical pieces are put together are consistent. So you have a way where if I have a business requirement to create a palette, I will have a method code unit that creates the palette. That method code unit is called from a function on the table. And from that table, I can then call it anywhere that I'm using that table. So wherever I am using the purchase line, I can just simply call the create palette function on the purchase line, which then calls the code unit that puts that business logic to use. And so if you do that, your application turns into something that's much more transparent. Based on those method code units, you have a very clearly defined piece of logic for which you can create tests that are easy to update, because the business logic for a single function is contained within a single object. And so by coming up with consistently applied design philosophy, a way of thinking about how you implement these business functions, the cost of your total cost of ownership will be reduced significantly. And it'll be, easier to implement new functionality as well, because your technical design thinking drives the way that you approach, creating new functionality. So this is what I'm talking about when we talk about the agent action business model. It's a structured approach to writing code where we transform business requirements into coding elements, which means that you take a business requirement, and everybody that works with product development or even custom client implementations will have some sort of methodology where you have a list of things that you work on, and those are called business requirements. And so if you have a way to implement business requirement in a certain pattern of coding elements, the way that you pick those things apart becomes a way of approaching a technical design in itself. So it becomes a conscious selection and usage of the coding elements based on how you're going to implement a business requirement. And so your development decisions become almost self-explanatory, which that's the key of a methodology, is because now we have a common approach, a common way of thinking, and so now we can learn from each other, we can teach it to others, and we can apply it to whatever situation is necessary. So the first thing you do is you determine any development, any business requirement by determining who is acting. And we call this the agent. And so the agent in development is always a table. And so I just want to cover real quick these elements. This concept is really an object-oriented programming concept. And since we are working with Business Central, and we know Business Central is not object-oriented programming, we don't necessarily have classes, but where we say class, we mean tables. So in the context of making apps for Business Central, when we talk about a class, we talk about a table, because that's the easiest way to kind of translate those object-oriented programming concepts to the way that we are going to be developing for Business Central. In some cases, it can also be a code unit, but that's only when there's no table inside of Business Central, but a code unit represents the methods of an external class. So this hardly ever happens. Most of the time, we're talking about tables. So in the agent action business model, you determine who does what, where. And so the who is the agent or the class or the table in Business Central, does what, and the what is the action, is the function or a method. And then the where is the context within that action. And so based on that, you have a business requirement. The business requirement covers a certain entity that generates a certain action, and that comes with a flow chart that explains that process. And so most business requirements do cover those three elements. Who does it? What do they do? And what's the context within that action? So that goes into our first concept called encapsulation. Encapsulation is one of four fundamentals of object-oriented programming. Those four fundamentals are encapsulation, abstraction, inheritance, and polymorphism. I have to say I'm not a computer sciences nerd, so I only know very little about what this all means. But based on the principles of object-oriented programming, is essentially what we're trying to say is we want to apply professional fundamentals, professional concepts towards designing solid business solutions. And by looking at industry standard accepted object-oriented programming techniques, we can take those lessons and apply them to Business Central objects. And so encapsulation is one of the things that we can actually accomplish. Abstraction, inheritance, and polymorphism are concepts that are not available to us because we don't do object-oriented programming, but encapsulation and decoupling are some things that we can approximate very, very nicely. It also means packing of functions into a single component and hiding methods in an object by building an impenetrable wall to protect the code from accidental disruptions. So basically what we're talking about is when we think about encapsulations, we think about taking a business requirement and tracing or translating that into a single object that does a single thing. And all the stuff, all the plumbing that is part of that process, we try to keep that within the object without exposing that to the outside. And so we'll go into what that means in a couple of minutes. Encapsulation is also a language mechanism to restrict access to defined components. In other words, be as local as possible. So one of the key things that we always try to hammer home in our workshops is using global variables, global procedures. Everything global is basically not good, except in certain exceptions. But other than that, we always try to be as local as possible. So take a variable, make that a local variable, and pass it into other functions and do something with that variable as a parameter rather than a global. Fields are declared on the class. So in object-oriented programming, that's called attributes on the class or properties. And these attributes on the class, for Business Central, we use the term, we use tables for class and fields as attributes. Methods, the functions, should always be declared on the class. And so when we have a function, for instance, calculate the item classification, which is a function of the item. So the item is the agent for the classification calculation. Then we create a method on the class. So the table, the item table, gets a global procedure called calculate item classification, but the method itself, the business logic, is contained within that code unit. So the screenshot is an example where we have a table extension that extends the item table, and we add a procedure, and that's not declared as a local, so it's accessible from other objects. So we can call item.calc item classification, and when we invoke that method, that really calls the code unit, and as you can see, it passes it passes the item record into that method code unit. And so now, anywhere in the system where we are using an item variable and we want to calculate the classification for that item, all we have to do is call the calc item classification method, and it'll do it the same way throughout the entire system. If we have to do some maintenance on the item classification logic, we have a single object, that's that code unit, and all the logic that is contained for all the logic that's related to that calculating of that classification is part of that single code unit. So any maintenance that's done to that method has to be done in just one single place. And by way of organizing the code, by way of making it a method on the class, we apply this as a standard way of providing this functionality. The advantages of this method declaration is you see explicitly which functions are existing for each table. So in object-oriented programming lingo, you say which methods exist for each class. I still think it's a little silly to talk about classes and methods, but the table in Business Central, we have tables and functions. And so by looking at IntelliSense, you have rec dot, and that shows, all the functions that are available for that table. And so it becomes really easy because you have access to the table. Now you also have access to all its functions. So you don't have to browse through the code unit list anymore to see if there is a function for something that you want to be doing with that item. All you have to do is declare an item, do item dot, and IntelliSense will show you all of the methods that are available for that entity, for that table. The methods are available on that table, but the methods themselves are not coded on the class. So the actual method itself, the business logic that is contained within that method, lives in its own code unit. So each method is a code unit of its own. So in the screenshot here, you see this is a screenshot of a list of code units. So we have a calculate item classification method code unit. We have an insert default values method code unit. and those are single objects that contain a single method. So we don't have a management code unit that includes methods for a dozen different things. No, each method has its own code unit. Now, I've talked about being local. This means that every method code unit only has a single global function. So in the screenshot that you see now, we have one procedure that's not declared as a local, and that one procedure is calc item classification. So at the top you see code unit 50,000. The name is calc item classification method. We have one local procedure that calculates the classification, and then we have a number of local procedures that function as subroutines for the main function itself. And we'll go into why we have those and why it's necessary to have those as a number of procedure calls rather than just putting everything into one single method. And so the method itself is always invoked through its class, which means, in Business Central terms, the function is always called from the table. So we have rec.calcItemClassification, right? So we don't call the code unit from other spots. Like what we could have done in the action trigger, we could have created a code unit variable and then have an item variable and then send the item variable into the code unit variable. But if this page that we're working on is already a page that is based on the item table, now we can utilize that and say, okay, I'm looking at the item table now anyway. That item table itself has a method to calculate the item classification. So I can call that directly from the page without having to declare any additional objects in order for me to be able to program that. And so the code unit that represents the method is never called directly, even though technically you could do that. But because we have a table function, it's just much easier to do it like that. So let's go into the next concept, which is readability. Readability, when I talk about readability of code, we're really talking about how the main function of each method is a readable flowchart of what the method does. And so I have a screenshot in the next slide that kind of explains that a little bit more. But basically, instead of having all the code in there, we take some effort into splitting everything up into steps. And so those steps, you have to think about if we're talking about a business process, you should be able to create a flow chart for that business process. And the flow chart has, boxes for each step in that flow, in that process. So you can think about that main method as a representation of that flow chart. So you should be able to take the business requirement in which you should have a flow chart. If you don't use flow charts in your business requirements, you should start doing flow charts today, because using the flow charts, you can translate that almost directly into function calls inside of a main method code unit. And so it should include all the relevant steps, and it should resemble understandable plain text. So it should be readable for quote unquote normal human beings. And so, we're all developers, so we should be able to understand when something goes into cust.get instead of get customer, even though cust.get is, that's syntax, that's programming syntax, so that's nerdy. Get customer is, also is a function call, so really inside there is the same stuff. So really you should be able to understand it as a developer, but in your main method, you should have function calls rather than actual syntax. And so all the business logic itself, all the coding itself should be split up into those steps out of your flowchart, and into each of those steps you contain the logic for that step within that the confines of that procedure. Because it becomes more readable, it becomes better able to be maintained. So this is a screenshot of one of those main functions. We have batch post warehouse cost. We have a number of function calls in there representing the steps in that flowchart. So we have a number of function calls, like one of them is called error if no posting date. That's almost self-explanatory. So we're going to show an error if there's no valid posting date. So if you go into that function, it'll check for the posting date. And it should not do anything other than checking the posting date. If you want to add another check, then either the check is part of the period checking or posting date checking, or you want to change a third thing. And so in that case, you would create a new function to check that third thing. And then you place that function call in the sequence of your flowchart in here. And so by structuring your code this way, it becomes a lot easier to read the code like this. And it was pointed out to me that in the clear general journal posting function, the L's look a little bit like ones, and they do. So that's funny. And another thing, I've said this before, you have to keep the functions to single task functions. And so the function has a single task. You don't put multiple tasks inside of a function. So if a function has more than one step, so in the previous one, instead of having 4 calls to do errors, you might have a function that's called check for all errors. And then in that check for all errors, you might have 4 different calls to 4 different categories of errors. You might be able to structure the code in that way. So it's a judgment call, right? So if you have 4 error calls, you think to yourself, this is becoming a little bit confusing, and they're always grouped by, I check all the errors as the first few steps. Maybe you can put those calls into a single error call, error function, but that function itself is then split up into other steps. And so you're not going to program a single error function to check 6 different errors, right? So you would create 6 error functions and then put that as 6 different steps into another function, right? So that's the key to organizing your code into doing a single task per function. Which takes us into decoupling. Actually, coupling is the degree of interdependence between software modules. It is a concept that was introduced sometime in the late 60s, early 70s by a guy called Larry Constantine. I know this because it's on this slide, and I looked at the wiki article and was very fascinated by this. So look this guy up. He wrote the book in 1975, Structured Design with Ed Jordan. Basically, the concept is where you have a piece of software that depends on other pieces of software. And when there is a change to one element, that precipitates into changes of other elements. So you have to think about a function call within a function call. If that function call gets an additional parameter, not only do you have some maintenance to the function itself because you have to add a parameter, but you also have to maintain the code that calls that function. And so the more intricate that system is, the more coupled that system becomes. And so decoupling is the process of removing those dependencies. And so loose coupling is a sign of well-structured software and good architectural design. And so the rule of thumb is loose coupling is good, tight coupling is bad, also known as low coupling and high coupling. Like I said, I'm not a computer science person, but I can understand that, having seen enough NAV code in my life, I see that, all these management code units that are almost some sort of network of interdependent functions become really difficult to maintain, especially when, functions call each other almost recursively, and it becomes really difficult to maintain. So those are the disadvantages of tight coupling, right? So a change in one routine forces a ripple effect of changes in others. Routines are hard to reuse because dependent routines must be included. So if you have loose coupling, and you have a a single method in a single code unit, and that is an independent piece of software that is just for that single task, you can port that task anywhere that you want. And so it becomes really easy to maintain, and it's much more effective that way. Calling the function from the table is already implemented, right? So we've already implemented this decoupling by calling out from our method on our table. This is only done in this one location. So if there's a change, if you change from one code unit to another code unit, you would keep the function declaration on the table the same. You just call a different code unit. And every implementation of that method in the system will then be changed simply because the method on the table, the function on the table, has changed code units. And so instead of having to go into each spot where that code unit is called, the implementation is very effective because instead of calling the code unit, you've called the method on the table instead of calling the code unit. And so assuming that the function declaration on the table remains the same, if the signature stays the same, you don't have to make any changes if you want to make a change to the code unit. And similarly, if the logic inside of the code unit changes, that has no effect on the method on the table itself or anywhere that that method is called throughout the system. We've talked about this before, calling the method from the table. So the code unit from the table, we have the item extension, we have the calc item classification, which calls the calc item classification procedure in the calc item classification method code unit, right? So that code unit has a single global function that is called from the table, and the table now has a method, a function that can be called anywhere else. And so that's the function of that method code unit. So the method code unit in the bottom, you see, has one procedure called calc item classification, and it receives an item as a record. Also part of decoupling, there's only one global function, and we've seen this before as well. So I hope you can see the pattern here. Within the calc item classification method code unit, we have a single procedure that's the global procedure, and all methods that are part of that flowchart are steps. All the steps in the flowchart has procedures that are local inside of the code unit. So, going into the global function, the calc item classification function, you can go in there and now you can see the structure of the global function itself. So we have a number of steps. First, we have a confirmation. Then we have an on before calc item classification event. Then we have the do calculate item classification. That's the main function. And then we have another event on after. And then finally, an acknowledgement for that. And so that's the main function. Those are the steps in there. So first we do confirmation, like that's a UI wrapper. Right? So the structure of the global function has a UI wrapper for confirmation. Then it has the first part of an event wrapper, which is the on before. Then we have a method header, which is the main function. Then we have another event wrapper for on after. And then finally, we have a UI wrapper to acknowledge the completion of this process. And all these steps are local functions. So you don't see all the ones here, but everything is local procedure except for the first, the calc item classification. So this guy over here is global. All of these are local functions. The UI wrapper, so we have a confirm calc item classification that passes the item record in there, and then we have a hide dialog boolean. And then it says, if not GUI allowed or hide dialog, then exit, and then we exit true. So that means we go on with a process, and otherwise it shows a confirmation message, and the same is for the acknowledgement. Now I want to say these are not obligations, right? You don't have to do a UI wrapper. So this is a matter of choices. If you choose to not implement a UI wrapper within the method code unit, that's a valid choice. But that would be a choice of you and your development team to make a conscious decision. Make a conscious decision to say, am I going to do a UI element in my method code unit, or do I do this on the page object? So do I implement a UI wrapper on the page object and then take care of calling the method code unit without UI wrapper or not? We chose for purpose of this video to include a UI wrapper in the method code unit just to show you that, and this is where you would put it. Then we have event wrappers, and the screenshot here says business events. You'll most likely put everything in integration events because most of the events, if not all of the events in standard Business Central are also business events or integration events, sorry. Business events are if you are dead sure that this signature of this event is not going to change. You might have noticed that we have a handled Boolean. A handled Boolean is basically to facilitate the ability to bypass logic. And so if you can handle the business case within the main function, or if you want to meet certain conditions and skip the processing, you can handle that in this event. And so by doing a handled Boolean, you provide the mechanism to extend the logic, and then by having this handled Boolean, and I'll explain in later slides how that interacts with the main function. So then you have the main function, do calc item classification, and as you can see, if handled then exit means if my event shows that all conditions are met and the business case is cleared, then handled is set to true, and then you can return that, and then it'll exit out of the logic based on that handled. And so this is, you implement a handled Boolean if you want to provide a way to bypass standard logic. So maybe you have like a price calculation, and you have a standard price calculation, but you also want to be able to provide a way to bypass the standard price calculation and give other developers a way to replace that method of price calculation with a different one. And that would be a mechanism that you can do that. Another way could be, this is where you can check for whether the license has been paid. So did the client pay for their subscription? If it didn't pay for the subscription, you set handle to true, and then it doesn't execute any logic, something like that. The on before main wrapper, in this case implemented by the on before calc item classification event, is the extension for that function. And in there, what you would do, the use case for the on before main, you do a preparation or a validation, in which case you would not send handle to true, and you have the addition or the exclusion, right? So this is where you say, I am going to subscribe to on before main, and then I'm going to check, and if I have additional logic, I can run that logic or exclusion logic. So instead of the standard process, I want to do something else. And if that executes successfully, then you set handle to true, and that passes back into main. And if exit is true, or if handled is true, it would just bypass that logic. And this is an example of, on before create palette, it tests the field for document number. It does not set the handle to true, but it does check that document number. And so if there's nothing in the document number, you'll get an error message. An addition or an exclusion, exit if already handled, exit if you don't want it to handle, disable. So that's in the scenario for the licensing, the subscription, if you've paid or not, and then exit if it does not belong to your sub-universe. In that case, you set handle to true. And then what you would do is you would respect the handled in your main as well. So closer look at the main method. In this case, we have a do create palette. If handled, then exit, right? So if that exclusion happens, if that other extended logic handled business case, then we're not going to do anything. Then the next step is error if not item line. Then we have an error if empty number. And then we have a step for do insert palette. And so as you can see, everything is local procedures, right? So even do create palette is a local procedure. That's not something that we expose to the outside, but the palette creation is done by this do insert palette function, which is a local procedure. You can also extend your own main method. So, in this case, in the do insert palette, we've added an on before insert palette record event. In this case, this is an integration event, just like everything else would be an integration event. And you can do something in addition to your standard logic. So in this case, the standard logic sets the number, document type, document number, and document line number. You could theoretically subscribe to the on before insert palette record and then set additional fields, and then that passes back to this main method, and then it inserts it. So this is a way to extend that logic. This is all contained within what we call a generic method pattern. So this is a little bit of an extended example where at the top you have the main procedure, and this is the at the top one is the global procedure. So the create palette procedure is the function that is declared on the purchase line record. So in other spots in the system, you would call purchase line dot create palette, and that would then implements the create palette method code unit where you have these steps. And so the top one is do create palette, which is the local procedure. That is your main function, right? So at first you have your UI wrapper, then you have your event wrapper, and then you have do create palette. And that's this guy. The main business process, the do create palette procedure, if I were to expand that, you would have these three procedures as function calls. Then we have a UI wrapper, that's the confirmation and the acknowledgement, right? That's up here. We have the confirmation, and then down here we have acknowledgement. And then those are implemented with an event wrapper where we have an on before create palette and an on after create palette. And then finally, we have the business extension, which extends the main business process to the outside world. And so this is an implementation of one of the design patterns. So you've already seen two important design patterns that we're going to be talking about next. The next section is about design patterns, and we've kind of already looked at a couple of important design patterns up until now, but let's talk about exactly what design patterns really are. Barter Knudsen, who was the principal NAV software architect, says the architecture of NAV is based on design patterns. Engaging in the NAV design patterns is the best way to really understand the software and learn how it should be enhanced. This statement was made before the introduction of Business Central, and so this was really applicable to NAV design patterns. But, of course, since we are on the same application logic, most of the design patterns that apply to NAV also apply to Business Central. So this is still a very relevant statement. So really, what is a design pattern? Design patterns are really things that you see return over and over and over again. So one of the examples that I always show in my workshops is the numbers. So every master table, every document table has a field called NO, and that's always a code 20 field. And those numbers are the primary key of those tables. And there is a functionality that's called numbering series that is implemented in pretty much the same way throughout the entire system. And so in the customer table, on insert, if the number is blank, then it goes to sales setup, it gets the customer numbers, and it gets the next number from that number series. The same in vendor. If the number is blank, it goes to purchase setup. It gets the vendor numbers, number series, and it gets the next number. The same applies to items, to sales headers, to other master tables and document tables. And so the way that that is implemented is called a design pattern. So in addition to what we've looked at before, where there is a somewhat implementation of an industry standard design patterns, we also have design patterns inside the application where similar functions are done in similar ways. And it's important as a Business Central developer to get familiar with those design patterns and use those to your advantage when you create custom functionality or product functionality. The Wikipedia definition of design pattern says, in software engineering, a design pattern is a general reusable solution to a commonly occurring problem. Applying design patterns is a standard way of coding in non-NAV contexts. There's in computer science, there's theories out there, and there are standard sets of design patterns that are applicable in various different contexts of software projects. If you're interested, go in and find out the design patterns, like the industry standard design patterns. Those are general, technical patterns that are used that you can use within the context of object-oriented programming, but also other types of implementations. The design patterns are not random or definable by anybody. They need to undergo validation and be approved. And to that end, there's been an effort by Microsoft to put together a design patterns wiki. This was a few years ago. I can't remember exactly how many years ago, but it was started, and there are quite a few design patterns that are in there that have gone through some scrutiny by the Microsoft team and have gone through evaluation and validation. And then it kind of lay dormant for a while. I know from some sources inside the NAV team that for Business Central, they want to revive their attention to these design patterns. So they have a plan to pick this back up. These design patterns still apply, right? So they are still valid design patterns, but they want to extend these patterns into also being based on event-based architecture and specifically to apps. And so the plan is to pick this back up and to have new design patterns and revise and re-evaluate whether this is still applicable. And so this is a community site, so go in there, provide your feedback, and they are looking at this. And so, like I said, they're going to pick it back up, so keep your eye out on it. We are going to look at 4 design patterns. One of them we've already looked at that's the generic method pattern. The author was Gary Winter, one of my fellow partners at Cloud Ready Software. Then we've also looked at the handler pattern that was written by Thomas Helsberg at Microsoft. We have something called a discovery event pattern, also authored by Thomas Helsberg at Microsoft. And then finally, the variant facade pattern written by Gary from Cloud Ready Software, and John Kaufman from Cloud Ready Software, and Waldo Erik Wouters, Cloud Ready Software. I don't mean to brag about this, and it's of course not a coincidence that these are written by Cloud Ready Software, because we include these patterns in our workshops, and so the workshop is the basis for this video. And so of course we picked ones that we were involved in. That doesn't mean that we think these are better than ones that we didn't write. There's a bunch of awesome design patterns. I just wanted to walk through these because we've put quite a bit of time into the presentation of, for instance, that generic method pattern. I think is one of the most valuable event-based design patterns out there. And so that's one that I also use in development project myself. So I'm not going to spend too much time on the generic method pattern because we've already gone over that. Declare each method. So you create a method as a code unit on its own, and each method is derived from a business case, right? So you have a business requirement. That business requirement results in the creation of a method, and each method is implemented in a single code unit. And that code unit is then declared as a method on its class, which is, a procedure on the table. And then you invoke that method only from its class. So although it is technically possible to call the code unit from pages, from action buttons and that sort of thing, the way to invoke the method is through a call from its class. So the table gets a procedure that has that method in it, and then if you want to invoke that, you do record dot table variable dot method rather than sending a record into the function directly in the code unit. Each method code unit only has one single global function, and local functions include the following categories. In that order, you have a main, which is a function, method header in the form of readable flowchart, and so I've gone over this, right? So all the steps in the main procedure should come almost one-on-one from the flowchart that represents that business requirement. Then you have a main business process, and those are multiple functions, right? A function for each of those steps. We have a UI wrapper, we have a business extension, and then we have the event wrapper. And our recommendation is for each of these method code units, you order the functions in that manner. And so if you do it like that, then your method code units will become very readable, right? So you always expect, like your UI wrapper to be in a certain spot. You expect your business extension to be in a certain spot. You expect your events, the published event, to be in the same spot. And so that's that fancy, colorful slide that we ended the last or the previous section in. This is the generic method pattern, and this would be an awesome candidate for creating a snippet. And I believe we actually have a snippet that I can show you toward the end of this video. The next pattern is the handler pattern, and we've talked about this. This was part of some of the functions inside of the generic method pattern. The handler pattern is used in the onBeforeMain event wrapper. We also have a use case for additive or exclusive business logic, and so this is a way to signify in additional or exclusive business logic to say, is my use case handled? And so the use case is derived from your business requirement. If your use case for that business requirement can be handled by onBeforeMain, then inside that code you would say, okay, handled is true, and that means that I don't have to execute the main code in our method code unit anymore because I've already handled my use case. So the description of the pattern is you pass a Boolean variable to all onBeforeMain events plus main. You do not execute exclusive mains if already handled. So the first line in your main function is if handled, then exit, right? So you completely bypass that if it's already handled. You define a subset of business cases in each exclusive main subscriber event. You do not execute exclusive mains if they do not belong to the business case. And so the handled Boolean variable is set to true if that case has already been handled. And so you respect that on both ends, right? So you have a subscriber to the onBeforeMain. In there, you might set handled, and then in your main, you respect handled. And so if handled is true, then you exit. You don't execute the business logic. And this is what that looks like. So in the onBeforeMain event wrapper, the event gets raised. And that's the onBeforeCreatePalette that has a red outline. Then you pass the Boolean to the event publisher, right? So you have onBeforeCreatePalette gets the purchase line that was sent into the CreatePalette main, or the procedure, the CreatePalette procedure. And then the event publisher has that purchase line, and we also pass it the handled, which is a local Boolean variable of that main global procedure. In the event subscriber, you respect the handler. So in that on before create palette disable, you have your business case, your business logic, and if that handles the business case, you set handle to true. And then in the main function, when you get that back, you go into do create palette. Then if handled, then exit, right? And I've said this before. So that's the handler. Next, we go into the discovery event pattern. The discovery event pattern searches for modules, functionality, behavior, or extensions that can perform a specific task or achieve a specific goal. It allows modules to advertise their presence to the application. Some examples in the standard application are service connections, assisted setup, and my notification. And I'm going to show you the assisted setup in just a few minutes. The pattern components is as follows. We have a discovery event that requests the discovery of the available modules. Then on that event, there is a registration method, which allows modules to advertise their presence. And then we have modules table, and the table contains information physically or temporarily about available modules. And an optional component is that you might provide a setup page ID or use to configure specific modules. And so let me just show you the way that looks. So in this screenshot at the top, you have the page 1279, the service connections. When that opens, it runs that reload service connections. And the first thing it does is it deletes everything. And then it runs the on-register service connection procedure, which is an event publisher. And so on the table 1400, the service connection table, there is that on-register service connection event. And when you subscribe to that in a code unit, so let's say you want to implement a service connection. This service connection is just a list of service connection that serves multiple pieces of functionality in the app. And so you can add your service connection to that list by subscribing to the on-register service connection event. And so what you would do is you would create a code unit. In the code unit, you have a subscriber to this integration event, and that sends in that service connection record. And that service connection record is a temporary table variable that you can then use the insert service connection method to register your service connection. And so in your subscription, you have a parameter, a service connection, and then one of the lines in your code is service connection dot insert service connection, and that's where you put that service connection into a service connections screen. And so the example that I'm about to show you is the assisted setup, which has a very similar way of implementing that. So this is an example of a code unit in which I have programmed. This is one of the demos in the SaaS user experience video. So if you want to see how this is put together, watch that video. I'll take you through this step by step. But this is an example where I have a company info wizard page, and I want to add that to the assisted setup screen. Now, the assisted setup screen is a list of assisted setup based on the aggregated assisted setup table, and that shows temporary records. And so those records are not stored in the database, they just show on the screen. And so that page has a spot where it refreshes these assisted setup. And so the aggregated assisted setup table has a on-register assisted setup event that I'm subscribing to. So I'm subscribing to that temp aggregated assisted setups on-register assisted setup event, and in there, that table, the temp aggregated assisted setup table, provides a method that says add extension assisted setup. And what that does is this creates a record in that list of assisted setups. And so for your module to be added to that list, all you have to do is subscribe to that register assisted setup. And that's the mechanism for the discovery pattern. And so this is one of the examples where that's really useful. And it's a very interesting pattern because it's not something that as an NAV developer you think about very much, but once you see the use of how this could work, with the service connection and my notifications and assisted setup, and there's a number of other examples that are very useful or something like that. So it's a very useful, common way to discover, to provide common functionality by having a list, and within that list you have access to functionality. It's very powerful. The next pattern is the variant facade pattern, which provides a single interface that can take any record or record ref or record ID as an argument. And so in here, there's a little screenshot, and in there we have a parameter variant record that is a variant, and we have an argument table. That argument table is different design pattern actually. So take a look at the argument table design pattern and see what that's about. The most important part of this guy though, the variant facade pattern, is that it implements one way to provide a single parameter that can be a variety of different things. So what's the problem? This screenshot shows two functions of code unit 229, the document print code unit, two different functions to print two different documents. And so you can see on the left-hand side, we have print purchase header, and on the right-hand side, we have print service header. The code inside is almost identical. There's some little differences, but it is necessary to have two functions because CAL is strongly typed. And the problem here is that most of these two functions are identical, so it's very difficult to see where the differences are and what really is the difference, but they implement very similar functionality. So if there's a change in the way that documents are printed, you might have to do it in two different places. Except there's not two of them, there's 12 of them, except there's not 12 of them, there are 20 of them. This is problematic because of a number of problems. You need to carefully read each block of code, and they almost look the same, so it's very difficult to discover the differences between those functions. And so if something needs to be changed, you now have to probably make that same change in all of those 12 or 20 different functions. And if there's a conflict in an upgrade, then the same conflict needs to be resolved in each of those functions. And then another problem is testing. If you want to do automated testing now, instead of having a single function that applies to all these different tables, you have 20 of them, and so you have to write 20 automated tests. And when you add a new document type, you also need to add additional function to this code unit with almost cloning the same code and applying it to the different table. The solution to that problem could be a print document procedure that takes a record variant. And so in that variant facade pattern, we try to provide a single interface that's flexible enough to handle the current and future usages. And this can take any record as a parameter, and we can keep record-specific code separate from common code. And that eliminates the need for cloning most of the code, and it makes this much easier to maintain. In this example, we have a single variant plus an arguments table. Like I said, the arguments table itself is another design pattern, and that's kind of optional. So, we start with a common code block, then we have some specific code blocks. So in that prepare record function in the middle, there are, definitely some record-specific logic like this shows. And so there are definitely downsides, but this is one way to take a look at how this can be done. And so these are some of the issues in that particular design pattern. It's not possible to find usages because it's not strongly typed. There are no errors at compilation because it's completely disconnected from the tables themselves, so it's harder to debug. Be careful with filters and marks if the function needs to support multiple records. A case statement can explode if there are too many tables that require specific processing. So there's definitely downsides to this particular one, but it was a design pattern that we came up with that implements, a single function for multiple tables. In the final section, I'm going to show you a snippet that was created to implement the generic method pattern. Just one short bit about snippets. So Microsoft has provided a bunch of snippets that comes with the AL extension for Visual Studio Code. And in the community, there are a number of people that are creating additional functionality, like an extension of the AL language extension. And one of them is the CRS extension, the AL language extension from Cloud Ready Software, which Waldo has developed. And in there, he's created a snippet for a generic method pattern. And so just to refresh your memory, the generic method pattern has one method for main, that's the main procedure, and then we have a UI wrapper, an event wrapper, and a business extension. And this particular snippet has this pattern implemented, except it doesn't have a UI wrapper. And so, like I said before in this video, it's really your choice whether to include a UI wrapper in a generic method code unit. But there you have it. So let me just go into Visual Studio Code, and I can show you what that looks like. So this is my workspace right now. I am going to create a new file, and I'm going to call it Daniel's method.al. One thing I want to point out is in the extensions, I have the CRS AL language extension, which includes that snippet. So part of that language extension is I type in T code unit, and you can see that the snippets that are provided there all have CRS in parentheses. And so there's this method no UI snippet. When I select this, it comes up with the snippet with the placeholders as you can expect. So I call it Daniel's method with the procedure that's called Daniel's method. And then take a look at what is created in here. So now the snippet's done. I have one global procedure called Daniel's method. So in my table, if I implement this in a table, I would create a procedure in that table that's called Daniel's method. And then I have a variable of that code unit, and I call this method because that's the only global procedure that's available. And that then has the event wrapper, and on before and on after as integration events. Those are the integration event publishers. And then I have a do Daniel's method procedure that respects the handled. So I don't know if when you were listening to me explain this generic method code unit pattern, you're thinking to yourself, oh my gosh, that's a lot of programming for every single method code unit. Well, you saw how quickly I created this particular code unit with the assistance of Snippet. So we've talked about, putting together some more snippets. I was thinking about, a snippet for, say, a master table. Maybe not a snippet, but some functionality, some sort of extension that creates all the object for a master table. So when you create a master table, it automatically creates a card page and a list page that has, global dimensions and numbering series and all that stuff already part of the snippet. But when you start thinking about that, it becomes pretty elaborate real quick. So this method, the generic method code unit, is a fairly simple object type. And so this is the kind of stuff that you can do. And so if you're in the community and you want to work on these things, you can actually submit them to the AL team as snippets. When you go to the GitHub page, you can submit an issue, you can put a pull request in there, and put the object in there. So very powerful stuff. That was it for today's video. If you want to learn more, go to this website, aka.ms/businesscentralapps, and there is a wealth of information in there. That leaves me to say thank you very much for your time in watching this video. I hope that you found it very useful, and I just want to say have a wonderful day.